Alrighty, guys, it is 7 o'clock and we are going to go ahead and get started. So hopefully we don't have too many more people trickling in here, but that's all right. So welcome everybody. My name is Garrett Barrio. I'm a Gensco DSG and I'm going to be going through Smart Multi installation with you guys today. If you guys have any questions, go ahead and throw it into the chat. We'll answer those as we go through, and at the end I'll open it up for anybody who wants to unmute their mic and ask questions that way as well. Before we get started too much, I just want to throw it out there for you guys that there was an email just came out here at about 6:30 that Mitsubishi has now replaced Kumo. So for those of you that absolutely love Kumo, I apologize. It is no longer. It is now the Comfort app. So be prepared for that. We're probably going to see some phone calls from customers today, wondering what's going on with their app. So if you guys get that call, just let them know that, yep, it's been updated to Kumo, or Comfort, excuse me. And yeah, it should work from there. So anyways, we're going to jump right on into this. Yeah, we're going to go over Smart Multi installation. Some of the stuff we're going to be covering through our presentation today is going to be, catch up with me here, screen. There we go. So I've got a few things we're going to cover. Branch boxes, when to use branch box, when not to. So City Multi and M&P, I'll go over the differences of those and when you guys know you need to order a branch box. Connection rules for branch boxes. We're going to be covering some of that in here. Your pressure testing procedures, evacuation procedures, proper way to do all that stuff, and how Mitsubishi would like to see it done, and hopefully help you guys out with some potential future failures, eliminate some of those. Wiring is a pretty common question we get. Addressing, most certainly, a lot of people still have some struggles with that. So we're going to be spending some time covering that, teach you guys how to address and what it means as you're addressing what you're doing. Dip switch settings, and common startup faults that we see on new installs, some of the most common things. So jumping right on into it. So branch box or no branch box. So you guys will need to use a branch box if you're using any M&P series and or equipment. So this is your MSZs, your SVZs, your PEADs, PLAs, all that kind of stuff there. With those indoor heads, you do not have expansion valves in the indoor head. And the Smart Multi heat pump does not have individual expansion valves for all of the indoor equipment either. So your indoor expansion valves or metering device is actually located in your branch box. So that is going to be required anytime you're using the M&P series product. If you are using a branch box, be aware that you can only go up to 36,000 BTUs per port on that branch box. You're not able to twin two ports together to get more than that. 36,000 is the max. So if you're trying to do like a PDA 42 or something like that, not going to work. Can't do it. When using M&P, talked about the expansion valves. A couple of things different too as well I want to mention on that is the expansion valve positioning. So that's one of the big differences between City Multi and M&P is one is your expansion valves being in the branch box. Two, on M&P, your expansion valves have about 500 different positions available for metering. Whereas without a branch box, when you're using City Multi indoor equipment, you have about 2,000 positions available for those things. So the way the system's meter is quite a bit different. Another thing is on the branch box, all your line set connections will be flare connections. So, and making sure that we have nice clean flares for all that stuff is going to be key. Hopefully, I don't know about you guys, but I always had the battery operating flaring tool. That was my favorite to use. It made nice clean flares pretty much every single time. Never had any leaks after that, and following proper torque specs for that as well. Without a branch box. So we can use City Multi indoor equipment on a Smart Multi heat pump without a branch box. So again, your expansion valve positions. City Multi would be like your PVFY air handlers. Pretty much anytime if you wanted to go over that 36,000 BTU for indoor unit, for a single indoor unit, City Multi without a branch box is going to be the way you're going to want to go with that. With the City Multi, the max indoor unit size is going to be 54,000 BTU, which is our PVFY 54. So if you guys are looking for something a little bit bigger, that is an option there. Can be used as a one-to-one application if you're doing city multi. So if you are looking to just do one big PVFY, 54, you can do it as a one-to-one. Just be aware that there is not an AHRI rating for that anymore. On the M&P with a branch box, there is, if you're using a single SVZ that is at least meeting the minimum requirements at the heat pump, Mitsubishi does allow you to do a SVZ as a one-to-one on a smart multi-heat pump, just FYI. But again, no AHRI rating for that. So if you're trying to get any rebates or anything like that, that is not going to be available for those. Line set connections on the Smart Multi, those are all braze connections. So again, no branch box to tie all your line sets to. So if you have multiple indoor units connected together, those are going to be done with pipes and T's. So braze connections, making sure that you're actually flowing nitrogen through that line set as you're brazing. That way you don't end up with carbon buildup inside there. It's going to plug up some strainers. So we are allowed to braze on our systems. You just have to use proper brazing technique in order to keep yourself from plugging stuff up. Connection rules. So if you guys are using a branch box, there are some connection rules for the amount of power draw that your indoor equipment can handle. So this is actually an app note that you can find in mylinkdrive.com under the app notes. It's app note 1039. And what you're going to find on this is covering for power factors for branch box. So all of your equipment does have a power factor associated with it right here. I know this table right here is a little bit older. It's for the older 8C and 4C equipment, but Smart Multi is still the same thing. And your indoor equipment is still going to be the same as well. What you got to be careful with is if you look at your branch box, you have a max power factor of 600. So that means if you've got lots of equipment on there, especially ducted units, you need to look at that power factor of that ducted unit. For example, your SVZ 30 and 36, they have a power factor of 300. So you can only put a maximum of 2 of these SVZs on your branch box. You can't do any other equipment once you hit that power factor. If you do get up to that max power factor, what you'll have to do is start powering your indoor equipment off of separate power itself. So providing a separate circuit to those things using a separate power terminal block, or SPTB1 is the part number for it. And yeah, this provides a circuit inside of your air handler. That way you guys can run a dedicated circuit and go over that power factor, because now that SVZ, if you're doing a separate power supply, is no longer added into that max power factor. So if you guys are questioning, how close am I to that power factor, you can use this chart right here found on MyLink Drive. Like I said, just go through, look for the equipment or the closest generation to what you may have, and use the power factor right there, and make sure that you're under 600. If you go over 600, separate power terminal block is what you're going to need. Highly recommend for those of you that don't, run your system in Diamond System Builder. You can get that on mylinkdrive.com for free. It's a free program to download for those of you that are not aware of it. Under the software tab, really great program. You can actually use it to build all of your jobs in there, which we highly encourage you do, especially as you start switching to the new 454B refrigerant types. There is going to be some requirements for square footage inside the homes. I'm not going to get into today. We are having 454 trainings happening. One of them is going on tomorrow. So if you're not signed up for that, take a look at Gensco customer, find your next available 454 webinar that we'll be teaching, and sit in on that. And we'll cover those room by room situation, square footage for the 454. Otherwise, like I said, this is just basic power factor. How much indoor equipment can you power by your branch box? So pay attention to that. Diamond System Builder will flag you if you go over. And if it does flag you, what you can do is go to the accessories, add that separate power terminal block to your equipment, and then it will allow you to not count that unit towards your total power factor. Pressure testing. So for those of you guys that haven't done it yet, you're going to need to make sure that you have a pressure regulator on your nitrogen tank that can go up to 600 PSI. So that is going to be a code requirement for the 454 product. So again, all that stuff is going to have to be pressure tested up to 600. So make sure you guys are updating your tools and getting your gear ready for that if you haven't already. Mitsubishi's requirement is it should be able to hold a 600 PSI pressure test for at least 24 hours. So I'm sure most of us, we don't have 24 hours bid time on our jobs in order to do that pressure test. I get it. So we try to do the best we can. What I recommend for you guys is, once you get to the job site, get your unit set and get that system on pressure test as quickly as you can. That way you can hold it on pressure as long as you can while you're doing your wiring, condensate trains, all that kind of stuff. Generally what I recommend for guys is, 600 PSI pressure test, absolutely every single time, no question about that. Or is the 24 hours, like I said, if you can get at least a couple hours of pressure test on there, go through, spray all your fittings with soap bubbles, make sure you have no leaks. And if you've verified no leaks on your fittings and you're able to hold 600 PSI for a couple hours, then chances are you're going to be okay. I would probably be all right with that if it was my job, just because, like I said, 24 hours. I don't think any of us would get any bids if we actually did that. If you can do it, that's a 2-day job. I'd highly recommend you do. When you guys are releasing your nitrogen from the system, or even before you start purging it, probably something I would recommend is purge nitrogen through your system, starting at your ports on the heat pump. Hook up to your suction side, pull your Schrader out of the liquid side, and just blow nitrogen through. Make sure you have flow through your branch box, through your heads, and then back out the other side of your heat pump there. I do get phone calls, new startups, restriction line, usually a kink, or somebody had forgot to take a cap off of their port when they hooked the line set up to it. Little silver discs that come inside the fittings. Every once in a while, I will get a call and find that one of those things did get stuck in there. So, like I said, I definitely, before you seal your system up, pull a vacuum, all that, make sure that you actually do have flow through your line set. It's going to save you probably some headaches on that.
Hey Garrett, can I mention something on this slide?
Yeah, absolutely. What do you got, Chris?
So I was going to mention that if your nitrogen gauge says 600 psi, a 600 psi gauge regulator, it is not going to get your system up to 600 pounds. So make sure your regulator is capable of at least 650. That way you can get 600 psi out of it.
Yeah, very good point. So I think a lot of the regulators we're selling them through Genscall want to say are 800 PSI rated. So Chris does bring up a really good point. Yeah, make sure that your regulator can actually test higher than what our testing pressure should be. And, keep in mind when you guys are doing pressure tests, we're trying to test above our operating pressures. So we can get up into 500 PSI. Under certain circumstances pretty easily. So you guys want to make sure that you're pumping up well above that. That way we're actually ensuring we're holding that pressure. I know a lot of manufacturers have recommendations for, 350, 400 PSI, whatever it may be. Usually that's because of the ball valves that they have on the equipment are rated for higher than that, and you can end up pushing refrigerant back into or nitrogen back into your heat pump. Whereas our ball valves, we are rated for 600 PSI, so you're safe doing so. So thank you, Chris, for that. Good point.
Welcome.
Moving on to the evacuation. Hopefully by now, everybody has a micron gauge, whether it's built into your gauges or you have something separate like what you're seeing in the picture here. We definitely need to make sure to be using microns when we're pulling vacuums on our systems. Triple evac is Mitsubishi can say required. I would say definitely recommended. If you're on a brand new job and you just ran your line sets, never been used before, do you have to do a triple evac every time? Maybe not. It's going to be up to you guys. If you can be able to pull it down, get it under 500 microns and it stays, you might be okay. If you have a system that has a lot of moisture in it, triple evac is going to be required. If you're working on an existing system and you open it up to repair a leak or replace a part, triple evac is going to be required. So to do that triple evac, what the expectation is from Mitsubishi is you hook your vacuum gauge up to the system or your vacuum pump, and you're going to pull it down with your micron gauge down to 4,000 microns. Once you hit 4,000, you're going to break that vacuum with just dry nitrogen. Do not open it back up to the atmosphere because you're just introducing moisture back to the system. We don't want to do that. So just bringing our pressure back up to a 0 psi, just atmospheric pressure with dry nitrogen only. The idea behind the triple evac is if you pull a vacuum quickly or too quickly that has a vacuum or has moisture in the system, that moisture will actually end up freezing inside your line set. So the triple evac is to change the state of that moisture from a ice form back to a gas when you're doing that, bring it back up to atmospheric pressure. So it gives your vacuum pump a chance to be able to pull that moisture out of the system. So that's what we're trying to do with the triple evac. And if you guys run existing systems, this will actually help your system pull down a little bit quicker if you do it this way. So first interval there, like I said, once you hit 4,000 microns on your gauge, you'll shut your pump off, shut your gauges off, then shut your pump off. And then, yeah, add nitrogen into that system until you get back up to 0 psi or so. You don't need to go crazy and go super high with bring it back up under pressure. Once you get back up to 0, you'll open your pump back up, open your gauges back up, or turn your pump back on. Next thing you're gonna do is pull it down to 1,500 microns. And then you're going to do the same thing. Pull it back, break your vacuum with nitrogen, bring it back up to 0, and then put it back on vacuum again. And then you should get under 500 microns. I'd recommend trying to get down below 500 as much as you can. I know new job sites, getting down to 200 microns, 300 microns, that's pretty easy. If you're doing repairs on existing equipment, it might take a little bit more work. But you want to get down under 500 microns, shut your gauges off or your hoses off, shut your pump off, and do a 1 hour decay test. So the goal is for you to be able to hold under 500 microns for at least 1 hour. If you end up coming up above that, say your microns rise up to 600, 700, 800 microns or so, that's chances are it's because you still have moisture in that system. So what you're going to want to do is if you do see that rise, put it back on vacuum. Let it sit on there for a while longer. If you're going back up over 1,500 microns or breaking vacuum completely, chances are that's because you have a leak in the system. So probably a real small leak that wasn't caught. At that point, go back to your pressure testing, 600 PSI. If it's a real small leak, what you might need to do is do the 24-hour pressure test or start isolating equipment. Test all your indoor units individually, all of your line sets, your branch box, whatever it may be, test that all individually and try to isolate it down until you can find that leak. So this is a very important step. As you guys, I'm sure most of you know, if you don't get a good vacuum on your system, any moisture will mix with your oil inside that equipment and the compressor, and eventually ends up turning to acid and leads to compressor failures. So we don't want to have you guys do that. We don't want to see you do that. Replacing compressors, I'm sure is a few of you are probably well aware, is not the easiest thing to do on the Mitsubishi systems. You have to pretty much take the whole unit apart in order to do it. If you guys are struggling to get your microns down past that 500, I'd ask yourself, when was the last time you changed your vacuum pump oil? So vacuum pump oil, once it starts getting dirty, guess what? That's considered part of your system while you're on vacuum. Your vacuum pump is trying to pull contaminants out of that oil as well. So what you're going to want to do is make sure to do regular oil changes on your guys' vacuum pump. That black gold isn't too terribly expensive, and it's going to be cheaper than replacing a vacuum pump, and it's going to save you time and give you a better vacuum. Usually what I would say is back when I was doing installs, new construction, new clean line sets, not a lot of moisture, you could probably get away with doing your vacuum pump oil every couple of jobs. existing systems where you're opening up to do repairs or your reusing line sets, anything like that, I would be replacing your vacuum pump oil every single time. Um, if it's a real bad, a lot of moisture and stuff in the system, a lot of contaminants, then you might be replacing your vacuum pump oil during your evacuation process. So something to keep in mind, keep up on your oil. That's going to save you a lot of time and a lot of headache.
Hey, Garrett,
Yes, sir.
one other thing here. So also if you have gaskets, right, O-rings in your
Yeah.
hoses, right? That's another one people don't think about. That's something you should keep on your van.
Yep, absolutely. Keep some replacements in there. Test your stuff there often. Inspect your
Yeah.
O-rings, make sure they're not damaged because little pieces of bark dust and gravel dust tend to get in there every once in a while.
Also, if you have a new set of hoses you've never used before, I had a new set that had 3 pinholes in each of the 3 lines. So I
All three
couldn't
lines had
pull
pinholes?
all 3. It's like somebody ran them over with something. So
You should
if
have
you
bought
can't
more
get
bark
it
pieces.
down, check your hoses. I just kept the ends, plugged the ends, and put them and dunked them in some water and found the leaks. So it can be anything.
Yep. So if you guys are struggling to find that, definitely test your equipment. Make sure it's your gauges and your hoses and all that kind of stuff is not causing problems. I too have had Field Piece digital gauges that had leaks in them and had to send them back to Field Piece to have them repaired, and they will do that. So if you guys have any issues like that, reach out to the manufacturer of your equipment and see if they can't do some repairs on it for you. Calculating additional charge. So all smart multi-heat pumps, you have to add charge to it. We get this call on the tech line for performance problems on smart multi fairly often. And one of the first questions I'll ask them is how much charge did you add to the system? And a lot of times guys will tell me that, oh, we didn't add any charge because we're under the 400-foot max that it says that we're allowed to do. So unfortunately, they are misunderstanding the instructions for these things. So the smart multi systems, the heat pump only comes with enough charge in it for itself. So any amount of line set you add, you'll have to add charge for. You'll have to add additional charge for all of your indoor coil capacity as well. So remember that. Um, Knowing the line set lengths on your system is going to be required. It's crucial. You have to know those line set lengths in order to properly charge this thing. When you guys are charging it, you're only charging it based off of liquid line. So you're not taking suction line into account when you're calculating charge. It is all based on liquid. So what you would do is we'll use this SM60 here as an example. So you'll notice the charge calculations right here is different between the SM36-48 and the SM60. The SM60 takes a bit more. So, but again, we'll use the SM60 here for as an example. So once you get your system all installed, you're going to need to go through and measure how long your line sets are. You're going to need to look at and separate 1/4-inch liquid line from your 3/8 liquid line. What you do is once you measure out all your line sets, figure out how long everything is and separate 1/4 from 3/8, you'll take all the 1/4-inch liquid line you have, times it by 0.29 in this situation, and that's how much charge you will need to add for your 1/4-inch pipe. Next, you take all the 3/8 liquid line you have, times it by 0.75, and that's how much charge you need for your 3/8 liquid line set. After that, you're going to add up all of your indoor unit BTU capacity. So, your 9s, your 12s, your 15s, all those, add that together. And whatever your total is, you're going to use this little chart. And this is in all of your guys' installation manuals. That book that comes with it, not an e-pad. What you do is add up all of your indoor equipment totals. Wherever you end up for a total capacity, you'll use this little chart. So if you're less than 27,000 BTU, that would be 53 ounces additional charge. 28 to 54,000 BTU would be 88 ounces additional charge. And then 55 to 78 would be 106 ounces of additional charge. So what you do is figure out where you land in this chart. Let's say, you're between that 55 and 78. So there's 106 ounces. And our example right here, they have 112 feet of 1/4-inch pipe at times 0.29 equals 32.48. are 3/8, 125 feet times 0.75, 93.75, plus our indoor capacity of 106, because we're between that 55, 78 for this example, 66,000 right there. So there is your total additional charge, 232.23 ounces or 14.51 pounds additional charge for your system. So on average, I see on the small side, usually I'd say 7 to 8 pounds additional charge required for your systems. And yeah, I have seen some pretty good sized systems with lots of indoor equipment, lots of line sets that can get up to that 14, 15 pound mark. So this is also going to be something important for you guys to remember on your sales side or your bid side. Anytime you're doing smart multi, refrigerant isn't cheap. That stuff is getting pretty darn expensive. And if you're not planning for that on your bid of having an additional 15 pounds of charge, you're probably going to be losing out on a couple $100 worth of refrigerant that's going to be required for that system to run properly. So if you guys highly recommend, again, Diamond System Builder, if you guys aren't using it, I'd highly, highly recommend it, because if you build the system in Diamond System Builder or DSB and put all your pipe lengths in there, it will calculate the charge for you and tell you how much should be in that system, so you don't have to do the math. This is an exercise that we do in our 2-day M&P class. For any of you that have taken that, I have found that we have about a 70% failure rate when guys are calculating by hand. So, and then usually my class, I'll follow up that exercise with using Diamond System Builder to show them how much quicker it is and how much more accurate it is just to run the system in DSB. The other nice thing with using Diamond System Builder, or even with this, is when you're doing your sales bids, if you build the system in Diamond System Builder, which you should be, because it's going to tell you your estimated BTU output for the system. It's going to tell you if you have a compatible system, you're following all the rules of the system, the additional charge, and it gives you a good ballpark for your estimates as well. So you can get an idea. You may not know exact pipe lengths, but you can get pretty darn close to what you're expecting on your bid and be able to figure out how much charge you're going to need for that and add that to your bid as well. So, anything else on that one you wanted to add, Chris?
No, sir, not at all. I'm just answering some questions here. There's a question here from Colin that says, is DSB available for mobile phones and iPads? Colin, no, it is not, and it will not be.
Yeah,
No,
Diamond
it's not
System Builder, it is not an app, unfortunately. So you do have, and it is does require a Windows operating system laptop or computer to be able to use it. So you do have to have a PC or laptop. Like I said, the software for that is available on mylinkdrive.com under the software tab. It'll be at the bottom of the page. Moving on. If you guys have questions on any of this, by all means, please give us a call on the tech line. We'll be happy to walk you guys through it and help explain it to you and give you help with all that stuff. So, alrighty. So wiring. When it comes to using a branch box, your branch box can either be powered by the heat pump, as you see here, or it can be powered separately from its own power source, own breaker. So just depending on what's going to be the easier application for you guys, however you want to do that. For the power wire going from your heat pump to your branch box or from your circuit to your branch box. So if you're going from the heat pump, there's a terminal on there called B1, B2, just screw terminals. That is what is powering your branch box. If you guys are using that, what's recommended is a single branch box, or if you're planning to upgrade in the future to dual branch boxes, if you're doing a single branch box, 14.2 wire will be fine on that for your power. If you're planning to run multiple branch boxes, or if you have plans for expansion in the future for multiple branch boxes, upsizing that to a 12.2 would probably be a good idea. It's not going to hurt it. So there's no communication happening on that B1 to your L1 or B1, B2 to L1, L2 in your branch box. It is just power happening there. It's just powering up your indoor equipment in that branch box.
So you don't need to use the cable tray wire, anything like that. That can just be standard Romex.
Correct. Correct. Now, once you get over to your indoor equipment, 16.3 wire with ground or 16.4. So it can be solid or stranded. I'd recommend stranded if possible. You're going to have a better communication on the stranded, less chance for issues with that. But Mitsubishi does allow for solid core wire on that as well. Some of the older systems had 14.3 listed in the manual. So far, I have not seen any major communication issues from guys using 16.3 and 14.3. I have not had any problems with that. New equipment, the Smart Multi recommends 16.3. If you can run 63, I would highly recommend you do. But if you got an older system that you're doing work on and they got 14.3 on there, I probably wouldn't go tearing up the house just to replace that wire. 14.3 seems to work okay. But if you are able to replace it, it may not be a bad idea. So that's from branch box to your indoor equipment. Now, your communication between your heat pump and your branch box, your M1, M2, otherwise known as MNet. This one is a very specific wire. If there's any one wire you're not going to screw up and you're going to make sure is the right one, no matter what, it is going to be this M1, M2. And that should be a 16.2 stranded shielded wire. So this is the wire that has all the communication happening from your branch box or all of your indoor equipment to your heat pump. So that one I have seen that where guys run incorrect wire size, they'll run a 14.2, Romex cable or whatever it may be, 14.4s. I do see communication problems happening from that just randomly. And if we do have that call, we go out to a site and we see that that is 14 gauge wire, not the proper 16.2, and you guys are having random communication problems, we will tell you to replace it. So make sure that this wire here, that M1, M2, or MNet, that is the 16.2 stranded shielded wire. Another thing I see guys make mistakes on, especially if they're using 14.4, because they didn't want to run two separate wires, is they will cross B1, B2. So they'll hook up one side of that 14.4 and B1, B2 here, but inside the branch box, they hook it up to M1, M2. So it ends up getting crossed this way. 100% guaranteed of letting the smoke out of that board. So I have never seen that method fail to blow up a board. And yes, replacement smoke is not available. You will be replacing boards in your branch box, if not boards in your heat pump as well. So what'll happen is you'll send that high voltage AC to that low volt DC, because that's only 29 volt DC on this M1 and 2, and usually ends up blowing the board in the branch box. And if you do it real good, you'll end up blowing control boards, MNet power boards, or a noise filter board in your heat pump as well. So another great reason to not allow your electricians to run a 12.4 or a 14.4 wire for their power, because they will try to use it on M1, M2 and very likely cross those and blow up boards. Another thing that needs to happen is this power wire and this communication MNet wire need to be separated by at least 2 inches. What ends up happening is your high voltage AC here does put off an electromagnetic field that can screw with your communication on our MNet. So at least 2 inches apart. I know a lot of guys like to run all their wiring and stuff and strapped to the line set inside of a line hide on the outside of a building. I'd highly recommend, if you can, if you want to run that line hide, fair, but don't strap it to your line set. Stick it on one wire on one side of your line hide, the other wire on the other side of the line hide. That way you can get as much distance between those as possible, so you don't end up with just random communication problems again. So that is going to be a lot of callbacks, a lot of nuisance callbacks for you guys if you don't separate those and don't use correct wiring. Let's see here. Moving on from that, I believe. Anything you want to add to that, Chris?
No, sir. No, sir.
So,
hey, did you see this? Sorry. Is there a way to review or watch this webinar again. So that was from Nate. Nate, sometimes they put these on Gensco customer. So you may see this webinar here in a couple of weeks. Matthew said, what if wire is shielded?
So you do want the shielded wire for M1, M2. So, and I kind of get that to you a little bit, but yeah, so on that 16.2 stranded shielded, there is a shield wire comes in there. That shield will land on your S terminals. Okay. If you pay attention to those terminals, you'll notice that it's only grounded to the chassis of the heat pump. It's not grounded on the branch box. We do not want that shield wire grounded on both ends. We only want it grounded at the heat pump. Okay. What ends up happening is if you ground that thing to both ends or all of your equipment, it no longer is a shield, it is now an antenna, and it will pick up all interference. So you definitely don't want to do that. Another thing, actually, I do want to add to this as well, just brought up another good point, is if you are doing multiple branch boxes, you are going to daisy chain this wire from your heat pump to your first branch box, and then from your first branch box straight on over to your second branch box. Same thing with your power wire. We don't want to run all those wires back to the heat pump. We just want them daisy chained from one unit to the next. So usually what I'd recommend is shortest route possible as well. So if it's shorter to run to your downstairs branch box and then up to the attic or vice versa, whatever it may be, just go shortest route you can. All right, so if you guys are doing wiring without a branch box, so you're using City Multi indoor equipment, what you're going to do is your MNet communication wire is going to go from your M1, M2 on your heat pump. All of your indoor equipment is going to have an M1, M2 terminal on it as well. So you're just going to run that 16.2 stranded shielded from your heat pump to your first indoor unit, daisy chain right over the second one, and so on and so forth for all of your indoor equipment. Again, it doesn't have to go to your lowest address, which I'll get into addressing here in a bit, but I would definitely route that shortest route possible. That way it makes it a little bit easier because there are some wiring limitations, which probably not going to reach on a residential system, but it's still a good idea just to keep those things as short as you can. And actually, here's my little spot about the shield terminal grounded to the heat pump only. So there's that. For City Multi indoor equipment, that cannot be powered by the heat pump. You have to run its own dedicated circuit for that. You can't have multiple equipment off of a single breaker, which is fine. You just have to size your system accordingly. Do recommend having an indoor disconnect switch at each indoor head though. So with this, again, this is without a branch box using City Multi equipment. You will need to have at least 2 circuits on this system for high volt, one feeding your heat pump and one for your indoor equipment. One thing I'd like to point out as well is if you guys do have a branch box that is powered separate from the heat pump, or you're doing City Multi like this, where your indoor equipment is powered separate from the heat pump, anytime you have separate power supplies, indoor disconnect switches, anything like that, those indoor units need to be turned on before the heat pump turns on. So what ends up happening is when your heat pump powers on, one of the first things it starts to do is starts looking for all the indoor equipment that's attached to it. If it doesn't see all that equipment pretty quickly, it just stops looking for it, it gives up. So that's why we need to make sure to have all of our indoor stuff powered on before that heat pump gets turned on. This includes power cycles or anything like that in the future you guys may be doing. Just remember, make sure your indoor equipment is powered first. Addressing. So whether you're using a branch box or smart multi or City Multi indoor equipment, anytime you have a smart multi heat pump, you do have to set up addressing. So the way that address structure works is addresses 1 through 50 are reserved for indoor units. 51 through 100 are for outdoor units. So if you're having multiple heat pumps tied to one system, that's why we have a whole wide range for that. How that address structure works is for your branch boxes, your branch box will automatically address all the heads connected to it, but you have to tell that branch box what is the lowest address connected to it. So for this, say example, we have just a 1-to-1. My indoor branch box, I'm going to address it as 0 because the first or lowest indoor address on that system is going to be 1. Sorry, address is 0, 1. That way you're telling the branch box, hey, address 1 is on this branch box. It says, okay, I'll start addressing those port A, B, C, D, whatever port may be used. It just automatically assigns it an address until either it sees a second address or it runs out of indoor heads. And then for your heat pump, I would say probably 99% of your systems, you're going to end up addressing your heat pump as 51 because it is your lowest indoor address. So in this case, address 1 right here, plus 50 equals your outdoor address. So that's what you end up seeing right there. That's how we got that 51. If you guys do have multiple branch boxes on your system, again, your first branch box, always your first branch box, you should be addressing it as 0, 1 because that's where your first indoor head's going to be. If you have a second branch box and you want to know how to address that, count how many heads are on your first branch box. In this example here, there's 3 indoor heads on this branch box, plus 1 more. So now address 4 is on this branch box. This branch box now becomes address 4. So the branch box, what we just did, we told it, hey, the lowest address connected to you is address 4. So it starts automatically addressing everything from there on. And now the system knows that, hey, address 4 is on a separate branch box and knows where to send refrigerant to and which valves to control.
Hey, Garrett,
Yes,
I
sir.
would love to add something here. People, if you have 2 branch boxes, it does not matter which one you pick as number 1.
No, it does not.
It does not matter.
Yep, it can
So
have
just
a single head on that branch box, and you can change it to 1, and
Yep.
have your branch box have 3 or 4 heads on it, or whatever you want to do. That branch box would be 2. So doesn't matter, correct? One thing you can do is say you have a 5-port branch box here, and you only got 3 heads on there for this example, because you're planning to do future expansion. You know this customer is eventually going to add a couple more pieces of equipment to this thing, but you don't want to have to readdress the system when you do. No problem. If this is a 5-port branch box and we're only using 2 of them, just skip those 2 addresses on the next one. So like this one to be address 1, because again, lowest address. Over here, if I got a 5-port, but I'm only using 3, but I want to keep those other 2 ports available, then I would take this address and make it address 6. That way we got 2 empty slots for when we do our future expansion. Because again, when you're addressing this branch box, your first one is looking for all equipment available until it sees this address here. So if it just sees 1, 2, 3, there's no more equipment, it says, okay, no more there, but the next address may be 6. Like, okay, now I know address 6 is on this one, continue on. So hopefully that makes sense to you guys. Again, if you have questions on that, feel free to give us a call on our tech line. We'll be happy to help you guys out with that and help get your system set up right. So how do we address the system? So this is looking at your heat pump. On the top right of your boards, you will see 2 rotary dials like this. Guys get very confused on the first digit, second digit thing here. Basically, if you address it at 51 to where it reads 51 as you look at it, 5 on the left, 1 on the right, you're good to go. So again, 51 on your heat pump, this will probably be 99% of your installs out there. The only time this is going to change is if you have multiple systems tied together. So they have maybe a central controller or some backnet controls that they're doing where they want to be able to run both systems off of one place. Then they tie it together and you'd have to do a little bit of different addressing with your second unit. If you guys get into that situation, I just encourage you to give us a call. We'll walk you through it. We'll show you how to set that up. It's really not hard, but it can be confusing for the first time. But like I said, for the most part, I'd say for 99% of your installs, this right here is how you're gonna set those address dials on your heat pump. So I don't know if you guys want to take a picture of that, a screenshot, whatever. That's what you're gonna want. Give you guys a second for anybody that wants to take a picture of it here. And then I'll move on. Okay, I'm gonna move on. If anybody needs to come back, let us know in chat, and Chris will let me know and I'll back up for you. On your indoor branch box, you also have 2 rotary dials in there as well. The only one you're probably ever going to really be playing with is this first digit. So SW11 dial. So you have SW11, SW12. SW11 is your ones dial. SW12 is your tens. So unless you're getting over 10 indoor heads, you're probably not going to ever need to really play with SW12. It's all going to be done on this SW11. Again, for pretty much every single system you do that's just a single branch box, this will always be set to just 1. That way you're telling it address 1 is on this branch box. And because you don't have a second branch box, you don't need to worry about adjusting any other addresses. So that's all you got to do on that branch box there as far as addressing goes. There's some dip switches that you need to set, and I'll get to those here in just a little bit.
Hey, Garrett.
Yes, sir.
So for those of you listening who have heard the old way of doing that, they used to say, put your outdoor unit at 55 and your branch box at 11, right? It's really hard to screw that one up. But if you were paying attention to the addressing structure for Mitsubishi, right? Your outdoor unit is 50 above the lowest indoor unit. So if you were to make your branch box address 11, that would give your lowest indoor unit address 11. So that would make your outdoor 61. So that was incorrect. So Mitsubishi says, please do not do that anymore. So if you're still doing that, I've run into some people who are, please correct your bad habits.
Yes, please use proper structure. So the nice thing with smart multis with a branch box that it is pretty forgiving on your address structure. If you screw it up, chances are it's still going to work. It may give you some hiccups now and then though. Addressing with City Multi equipment is a little bit different though. So City Multi equipment I found is definitely a lot more sensitive to addressing. If you screw that up, you're going to have problems. So the way it works is the address structure is the exact same. Doesn't matter if you're using City Multi equipment, if you're working on a big R2 commercial job, or with a branch box. Your address structure remains the same. How you set those addresses might be a little bit different though. So because on City Multi we don't have a branch box, you have to manually address all of your indoor equipment on your own. So what you'll find is on all City Multi indoor equipment, you're going to find 3 rotary dials like you see here. SW11, again, is your ones digit. SW12 is your tens. SW14, you should not ever touch that. Not on this smart multi system. This is if you're using a PURY or otherwise known as R2 systems for commercial jobs where you have a branch controller. That would be what that is for. So not used in this application. So smart multi, that should always be at 0. With the City Multi stuff, you have to address all of your indoor equipment. So if you have 3 units on there, you're gonna have to go through all 3, tell one of them, hey, I'm address 1, next one is address 2, next one will be address 3, or whatever you may have set up. So just be aware of that with City Multi, you do have to set the address on all equipment. And again, if you mess this one up on the City Multi indoor equipment, it's going to be more temperamental than it will be on branch box systems. So be aware of that. Okay, moving forward, dip switch settings. So this is your dip switch settings with the branch box. On your heat pump, here's a nice little view of the current generation smart multis. New 454 stuff is going to change. All your switches are going to be lined up, but it's going to be very similar. And on 454, you won't have to worry about this SW2 switch 5. Don't need to do that anymore. But on our current generation smart multis, on the heat pump, this is the only dip switch you will need to turn on if you're using a branch box. So I'm not sure how many old school guys we have in here, but we used to have the PUMYs and the 8C outdoor units. They were the same outdoor unit. It's just the difference was is this dip switch right here. So a city multi equipment versus branch box. SW25, if you're using a branch box, that will need to be turned on to tell it that there's a branch box. Again, the system will operate with a branch box with that turned off, but it changes how it meters flow to your indoor head, so your performance may suffer a bit. So that's something we usually look for when we're doing our phone support and site visits to make sure that that switch is on if they have a branch box. Actually, this is a really good screenshot for you guys, for anyone doing the one-to-one application. Because right here on your heat pump, there's your address dials already set up with that SW25. This will be that 99% of your installs right here. So if you're doing a branch box, this is exactly for this switch and your address dials, exactly how your heat pump should be set up.
Yes, just the address dials and your SW2.
Yep.
None of the other dip switches.
Correct. A lot of these other dip switches, those are for model selections for heat pumps and stuff like that. Don't need to mess with those, but just this switch and your address dials, anytime you have a branch box, is going to be set up just like this. So this would be a good picture for you to take a screenshot of. On your branch box, there are some dip switches in there that you will need to set as well. So you can see our rotary dials here for our addressing. Right up next to that is the SW1 dip switch bank. Okay. What this is dip switches for your port assignments. So you're telling the branch box which ports on that branch box are being used. So for those of you who have already installed these, I'm sure you've seen, port A, B, C, D, and E. That associates with A being switch 1, B, 2, 3, 4, 5, and so on. I know that there's only 5 port branch boxes max, and we have 6 switches on here. Don't worry about that. Switch 6 just always stays off. So it doesn't have any real function. If you guys want to get creative and put like some cool RGB lights in there, or a disco ball powered off of 6, that'd be kind of cool. Send us pictures. I'd love to see it. But otherwise, what you're going to do is, like I said, if you have a 5-port branch box, and let's say for this example here, we're using ports A, B, C, and E, then we turn on switch 1, 2, 3, and 5, like what you're seeing right here. So D port's not being used, switch on that stays off. And it can be any combination of those. So depending on which ports you're using, that's what you're going to set here.
So one thing to add to that, Garrett, is Mitsubishi said they would like you to use these in order.
Yes.
Right now, keep in mind that on a 5-port, we have E on here. E is your 1/2-inch suction. So if you do have a 1/2-inch suction, you can put it there and skip one. So other than that, if you have all 1/4, 3/8 lines, they prefer that you use them in order.
Go right down the line. They don't want you to skip ports, but can you? Yes. But anyways, so yeah, making sure that you turn those on. Some of the older equipment, you'd be okay if those weren't turned on. May have some performance problems, but the system will still work. With the newer generation equipment, what we're finding is that if these switches are turned off, it turns off that communication to that indoor head. So if you guys are doing a startup and you're having a communication fault on indoor equipment and you have a branch box, check these switches, make sure that they're actually turned on and nobody forgot about them. It's a pretty common one for us. Dip switch settings without branch box. On the heat pump, there are no dip switches that need to be changed. So the SW25 switch will stay off because you don't have a branch box. If you turn that switch on and you're using city multi-indoor equipment, so you don't have a branch box, it is going to give you an error code, and it's going to be for incompatible equipment combination because you're telling it there's a branch box in the system when there's not, or and there shouldn't be. So if you see that, that's why. Check your SW25 with city multi-equipment, make sure that it is turned off. As far as other dip switch settings for your city multi, unlike your M&P, all of your function settings for your indoor equipment, your temperature sensing location, your heat strip activation, your thermal fans, all of that stuff is going to be done using dip switches on your indoor equipment. Same thing with static pressure. Your static pressure will be set using dip switches on the indoor. For that, I would be looking at your installation manual and your service manual to figure out exactly what those dip switches are and how to set them properly. So that would be the place to look for those. If you guys aren't aware, the only manual that comes with your equipment is going to be the installation manual. So if you're looking for the service manual, mylinkdrive.com is where you will find that. So any service techs out there, if you're going out to a job, don't get mad at your installers for not leaving a service manual. It didn't come with one. Common startup faults. So this is just a quick list of some of the stuff that we see pretty frequently on the tech line for guys calling in for new systems. Incorrect addressing, incorrect wiring, crosswire between high voltage and the communication blowing up boards. We discussed that. Incorrect dip switch settings. Heads crossed. I put heat pump. I need to fix that. Heads crossed at the branch box. So one of the things when you guys are doing your startups on this, what you should be doing is testing your system in both heating and cooling. There are options to test run those things either through your thermostat or maintenance tool if you have your maintenance tool hooked up. But I highly recommend that all of your systems, whether it's Smart Multi or MXZ ported units, you test each head individually in cooling. So very, very commonly, guys will swap on accident the wiring at the heat pump or the branch box with another head. So essentially what ends up happening is, for example, head A starts calling, but it's wired to port B at the heat pump or the branch box and starts sending refrigerant to the wrong head. Heating mode, it is very, very difficult to detect this because anytime you're running in heat mode, you're sending hot gas to all indoor heads. Cooling mode, you're hitting your expansion valve before it gets to the head, so it's a different story. So what you'll do is put those units one at a time in cooling and make sure that the head that's calling it is actually getting cold. And checking the other heads to make sure that those ones that are off, that the coil's not starting to freeze up or get extremely cold, anything like that. That's usually what ends up happening. And we get this call a lot in the summertime of, hey, I have indoor heads freezing up on me. The number one cause for that is because it's wired wrong. You're sending refrigerant to the wrong indoor unit. So again, all startups, you guys really should test cooling mode, each head individually, just to make sure that it's wired correctly. Incorrect charge added. Like I said, with these units, you have to add charge no matter what. So be aware of that. And I would highly, highly recommend and encourage you, write that total charge or the additional charge on the outdoor unit, like inside the cover. That way, you guys, when you have a service tech coming back or anybody's following up behind you and they're questioning or I'm questioning them, hey, did anybody ever add any charge to the system? They can find out right away. It's really annoying when we're having performance issues and we don't know if the installing team ever actually added the charge or not. So trying to write that down to let somebody know that, hey, this is what we added is going to help out your service guy a lot and us. Another one is the incorrect power startup sequence. I talked about that. If you guys see on your heat pump, there's a LED or LCD display on there. If you're seeing just ones on that display, that is not an error code. Those are what we call status flags, and I'll show you what those mean here in just a little bit. An actual error code is going to pop up with a 4-digit code on the heat pump: 4100, 4250, 7102. So 7102 is a very common one that we see on startups. That's a code for total capacity of the system, either underconnected or overconnected. Usually when I see a 7102 on a new startup, it's because it's looking at underconnection. And what people will end up having issues with is incorrect wiring, cross wiring, power sequence, all those things can affect that. Condensate pumps on wall heads not wired up right, that kind of stuff. on the smart multi, if you guys are seeing some of those common startup faults, that system does have its own onboard diagnostics. So there's a dip switch bank on the heat pump. I think I had a picture of it back here. Yep, right here. SW1. It is an 8 switch bank. It's the largest of them you can see right here. Middle row, left-hand side. This dip switch bank right here is used for onboard diagnostics. So all of your other addressing, dip switches, function settings, all that stuff is going to need to be done with power off. This switch right here is going to be pretty much one of two that can be done with power on, because this is not changing any functions of the system. It is just looking at different data points. For those of you that are lucky enough to have our Gensco Tech manual, there is pages, I think it's 48 and 49, I want to say, has some of the most common dip switches that we use on our tech support side to look at different data points in the system. If you guys don't have one of our Gensco Tech manuals, get on your Gensco customer account, and under the Tech Services tab, you will find our tech manual on there. Depending on how you set those dip switches, like I said, you can look at different stuff. So if I'm seeing, for example, a 7102 error code, very commonly we see that one for when, like I mentioned, it's for overconnected or underconnected. One of the first things I'll do is I'll come over to SW1 with power on and flip on switch 3, 4, and 6, and my LCD display will tell me how many indoor units that heat pump is seeing. So if I see a 7102 and I come over here and flip these switches on, I know I have 5 heads on the system. I flip it on and I only see 0 or 1 or 2 or something like that, then I know I'm having communication problems with my indoor equipment. So start doing some diagnosing on that, checking for, crosswire. Did they swap S2, S3? Do they have the Mnet hooked up? Did they run the wrong wire? Is things powered? Going through testing and all that kind of stuff. Like I said, there's a lot of. Yes, sir.
I don't know if you mentioned this, I just stepped away to a phone call, but another way to verify your connected units is on your branch box.
Yep.
There are 2 lights on your branch box.
Anytime. I was going to get to
that. Okay, all right. Sorry, I'll let you continue. Sorry.
To finish Chris's sentence, there are 2 lights inside your branch box, LED 1 and LED 2. LED 1 will be lit anytime you have Mnet power. LED 2 should be blinking, depending on the generation of equipment you have. Some of the older stuff, it doesn't do it, but the newer stuff does. So if you're wondering if your branch box is talking to the indoor heads, look at your board inside that branch box. Look at LED 2. It should blink for how many indoor heads. So if you have 3 heads, it should blink 3 times. If you have 5 heads, it should blink 5 times. If it's not blinking at all, that tells you your communication problem will be probably between branch box and indoor head. Like I said, with the smart multi dip switches, there's a lot of stuff that you can look at. Individual coil temperatures inside, pressures, compressor speed, subcooling targets, discharge temperatures, all kinds of stuff. So these are, like I said, in our book here you're seeing. You guys can take screenshots of this too if you want. But these are some of the most common ones that we use. If you look in the back of your smart multi-service manual, there is pages of different switch settings that you can do to look at different values. Another one I'll look at quite commonly is if I suspect guys' systems are crosswired, like, port A is wired to port B or head A is wired to port B. I can kind of see it using dip switches as well. If we go, somebody tells me, hey, I know I got a 6, a 9, a 12, and a 15 ports A, B, C, D. I can come over, use these dip switches, and see what head is connected to which port. So the weird thing about it, it's going to give you a QJ code. So if it's a 6K head, it's going to say 4, but translates over to 6. If it's a 9K, it'll be 5, and so on and so forth, like you see in the chart here. So if you guys are seeing that 7102 error code, like I said, I'd be looking at indoor unit connected, make sure it shows all indoor units that you have, or however number of them you do have. If it does show that, start looking at these capacity codes. And if you have, say, one's reading 0 or one's reading 50, but there's something connected there, it could be a power supply issue that or a communication problem. Or in the example of a cross port, like I said, if I know port A, B, and C are a 9, 12, and a 6, and I come here and I look, okay, port A is not a 9, it's actually the 12. What's going on here? Then guess what? Now I know that that system is probably cross-wired. If we know our line sets are connected up, but our wires are reporting the sizing wrong, that's another little handy tool you can use. As far as those ones, those status flags I was telling you guys about that you will normally see on your display, this is what they mean. So if you have a 1 in segment 1, LED 1 there, it means your compressor is on. Segment 2, your 52C relay is closed in the system. So your 52C relay is on, can be in your power board or control board, depending on the unit. But that's a relay that closes once the system is getting ready to start. 21S4 is your reversing valve. And then you have solenoid valve 1, solenoid valve 2. Those are generally for capacity stuff or different various functions. So it just tells you what is being energized or what is currently active. And then in your last segment over here, if you have a 1 there, that just means there's high volt AC being supplied to the unit. So that if you're seeing ones, that is what those ones mean right there. Again, if you see ones, it's not something to panic over. That's a good thing. It means there's no active air code on the heat pump. If you guys have an active air code indoor, but it's not showing in the heat pump, use your SW1 switches. Start looking at your most recent air codes stored in the heat pump. With this, you can use those switches and look to see what all the air codes stored are. Just got to be careful because there's no timestamps associated with those, but you know, you're looking at your most recent one. If you're having, you know, startup issues, obviously it's going to be the most current one there because you just started the system up. It hasn't been running for a couple of years. Anything else to that you want to add, Chris?
No, sir.
All right.
No, sir.
All righty, guys. Well, that is what I have for you today. So we went just about an hour there, so that was perfect. How we doing on questions in chat, Chris?
We're doing good. We just got one. Does the maintenance tool allow you to see this information live?
So it does not allow it. Well, kind of. So what it does is your maintenance tool will give you a 1-minute update. So every minute it will update maintenance tool. And yes, it will show you all those thermistors, your expansion valve positions, compressor speeds, everything you can see on those dip switches. But the nice thing with the maintenance tool is you get a nice clear picture of everything all at once. So whereas with the dip switches, obviously it's kind of hard sometimes because you're going through and just flipping dip switches and looking at different things constantly back and forth. So it can, after a while, it can get a little muddy if you're trying to do a lot of diagnosis and without taking good notes. So be aware of that. But otherwise, yes, maintenance tool will help out quite a bit for that kind of stuff. Let's see here. Can we send a slide deck out? Probably not. What you guys will do is I will ask to get this presentation put up on Gensco Customer and probably YouTube as well. For that slide deck, if you're wanting a cheat sheet or anything like that, look on your Gensco Customer account and see if you can't find that tech manual on there. If not, talk to your outside sales rep and he can get you one. Or look in the back of your service manual. What is a pole box? I'm assuming, Isaac, there, your question for a pole box is back on the city multi stuff. Let's go back real quick. So right here, pole box, that is your indoor disconnect switch. I assume that's what you were looking for.
I had a question on the that dip switch page you had up there.
Okay, let's go back.
Well, basically just finding it. That's the first time I've laid eyes on that, and I don't think that's in the service manual.
So that
Oh,
one right
no.
No, not that
No,
one. Yeah.
no, the one from the tech manual, I think he's talking about, the one with the yellow dots on it.
Yeah. Wow.
One.
I think
Okay,
I've ever laid my eyes on that.
that is in our Gensco printed tech manual. So if you do not have any of those, please reach out to your OSR and have him get you some.
Well, Roger that.
Yeah, so that's something that we put together just to help help guys out in the field. Just because the actual service manual is not nearly as clean and as nice and as this manual here is what you're seeing.
Yeah.
So, yeah, that's something that we put together on the Gensco side.
Oh, that's great. I mean, I do use a lot of MyLink Drive for grabbing tech manuals.
Yep.
But I was hoping I wasn't missing out on something. So okay, so reach out. So that will be our Gensco.
Yes,
Not
your
yet.
rep.
Okay.
Yep.
Okay.
And it's also on Gensco customer, so you can get a digital copy of it on there as well.
Okay.
Yes,
I'll
that is
explore that.
correct.
Yeah.
Stan has a question. Can the codes be cleared from the outdoor unit with dip switches? Yes, they can. Any error
Yes, if you
codes?
guys have an error code, SW2 switch 2 on your heat pump will clear that error code. So
No,
Where?
three clears the error code.
you're right. Switch 2 is yeah.
2 is for your clear connection history
Yeah,
for
clear
your indoor units if you mess up the addressing. Now, I don't know if you mentioned this, if you set incorrect addressing and you have to change it, addressing is set with a power off.
Yep.
So when you find something that needs to be corrected, you power off, wait for lights to go out, you change your addressing. Now you can do one of two things, is leave the power off for 30 minutes and your outdoor unit will forget what it saw. Or you can turn on 2-2, SW2 switch number 2, and power it on for 2 minutes. And then when that 2 minutes is up, power it off, wait for the lights to go out, and then turn off 2-2. And that will, when you start it up after that, it will go get a fresh look at all the addressing. So as far as clearing the error codes, SW2-3 with the power on, you can do that at any time. It only needs to be left on for about 5 seconds, and then you can turn it back off. If you ever run into, say on this page here that's up, if you look for the abnormality code history and you flip that dip switch on, 1, 2, and 4, and you get a 8,255, that is not an error code. That is a code that tells you there are no stored error codes, which is kind of weird.
Yep.
So
Thank
there you
you,
go.
guys.
That's all I got.
Going through the chat, looks like Vlad had a question. How would you address the dials on branch boxes, one 5-port and the other is a 3-port? So again, if you have 2 branch boxes, let me go back to this slide here. Right here. So if you have 2 branch boxes, one of your branch boxes is always going to be address 1. For your second branch box, if you're trying to figure out the address for that, count how many heads are on your first branch box.
And
If you
add
have
one.
3 heads, just add 1. That would be your address for address 4. So if you have a 5-port branch box and a 3-port branch box, if that 5-port was your first one and you are using all 5 ports, then your second branch box would be address 6. So just count how many heads you have on the first branch box, add 1. That's your address for second branch box. So hopefully that answers that question. Gensco has maintenance tool. Yes, we do. I'm not sure what our availability of stock is. If you're looking for a maintenance tool, talk to your local branch. So there are for this system here for the Smart Multi, you need the MN converter, which is the red box with cables that hook up to M1, M2. And if you're looking for assistance on how to set that up, give us a call when you're on site with it, and we'll help you out. Hopefully you guys have internet access. If you guys have maintenance tool and you're on a job site with a laptop and you have internet access, we can have you download TeamViewer on your computer. It's free to install, and it gives us the ability to remote access your laptop and help you out and looking over data with you guys live. So we do have that availability. Download that too, can't you? Not sure what you were talking for there, Nate, on your question. Back to 2 branch box question would be the address. Hopefully I was able to answer that question for you there, Vlad. What would the address be in the outdoor? 51.
I think Nate was referring to, can you download that to
Tech manual.
right, the tech manual, so you can download it or view it on Gensco customer under catalogs.
Yep. So you can download it there. It's a PDF. All right, guys, we'll give it another couple of minutes here. For anybody that has any other questions, you're welcome to unmute your mic. You guys have permission to talk, or if you want to just throw your question in chat, you can do so. Otherwise, if you guys have no questions, I got nothing else for you. So that's the end of it. So have a great day. And yeah, if you need any help, give us a call.
Bye.
Give it just a couple more minutes in case anybody else wants to ask a question, and then we'll shut her down. You guys are welcome. Hopefully you learned something.